now, and if I have it right, everyone can see my screen. Heather, your group can see my screen.
Yep.
Okay, go take it away, guys.
Alrighty, so here we go. All right, hello everyone. We're Outer Shield, and thanks for coming to our intro for the pitch that we have.
All right, so this is Auto Shield Overview. It is a 3D printed project to make a CRAM, which is a counter rocket mortar artillery. It is for protection of armored vehicles. The alternative use is to make an automated system to track objects, which could be used in automated farming, harvesting, pest control systems, excuse me. We wanted to make a small scale prototype just to show proof of concept of the technology. The real one would be a little bit too expensive. The prototype uses a Google AI-wide camera to recognize RPG warheads and send coordinates to the servos based on a bounding box. Finally, we had a team member, Corey, create an IR proximity sensor to determine if the RPG was close enough to engage the mechanism. Go to the next slide, please. This is our team. First, we have Martin, who's mechatronics, Jared, precision machining, myself, Orion, who's a CAD drafter, and Corey, who is also in mechatronics.
So how we started, so at the beginning of this quarter, we had to brainstorm some ideas, so how to improve our community. So my idea was to improve our better armored vehicles for our militaries out there right now that will fighting for us. Yeah, and we came up with this idea, so we can improve the armor itself, or any weapon capabilities, or anything that can sense the incoming threat from either from RPGs, rounds, anything like that.
So our mission statement at Auto Shield USA, we are a company that puts the lives of our soldiers first. We are committed to researching and fabricated automated protection solutions for U.S. military vehicles and personnel. Our focus is listen to soldiers that have been in war, and using their ideas, we make APS systems more efficient in protection detection. And then there's our little logo there. So how this will improve our community. Our idea came from a veteran who wanted a safer military vehicle, so we hope our idea can be one that can better protect the people who protect us.
So these are our initial sketch concepts. On the left was the very first idea, which was basically the parts that we had and the mechanisms we needed. And then the right was a more fleshed out idea of how those parts would be combined and used. You can go next slide. These are the CAD models. The first one on the left was made in CATIA, but there were some save issues and this model had to be abandoned. So I recreated it in SolidWorks, and the picture on the right was not the final design until we had the servos moving to make sure that nothing would, that everything would connect properly. So keep going. This is the assembly drawing, and this shows all the pieces. I'm still learning SolidWorks. I've been familiar with CATIA for too long and need to practice on SolidWorks. So not everything is up to date. Next slide is the parts that we wanted to machine. We didn't get a chance to do that this quarter, so maybe that'll happen some other time. But that was the base plate, and it would hold, everything would be rotating on the top of that. We can go next slide. This would be the second part to machine, and we chose these two parts because they would be sliding against each other, and that's where the most friction would be. And with the 3D printing, there can be a little bit of friction, and it's not exactly precise in the measurements for how they come out. Yeah, next slide.
All right, so the idea of why we chose this idea to stop the incoming for, like, for example, the RPG is that the netting that we can see on the image, it gets really hard, like whenever we try to open doors and all that. Yeah, and the idea is that we can use this CRAM to shoot a net, well, similar to the ones on the image, so we can stop the incoming threat, like at RPGs. As we can see that whenever the front part of the RPG is hit, all the explosion will come out and penetrate through the armor and explode inside and destroy anything on its path.
So here is a simple infrared proxy sensor. An infrared proximity sensor works by basically a pair of LEDs. One LED shoots an infrared beam out, and when that infrared beam reflects and is noticed by the other, the receiver LED, there is an LED that will turn on for the incoming threat. If you can kind of see, it's hard to see, but there's a little circuit board, and when this white circuit board gets close to this clear and black LED, it actually turns a red LED on or a yellow LED on the white board on top. So on the right side is kind of a rough idea or an infrared proximity sensor, I guess, unit, all enclosed in this wooden box. Next slide, please. And basically, this is on the left-hand side is an overall wiring diagram of what you just saw. At the top, you basically have power coming in. You have a push button to activate the system. A green LED turns on to let you know that you have power on. And then we go through a voltage regulator. On the left-hand side is Orion's face tracking detection CPU. And then it also comes with a camera. And that also talks to my infrared proxy sensor, which is over on the right-hand side. And there is a red LED that will turn on once again when it detects incoming threat. And both these computers will talk to each other, and the motors down at the left-hand side, or servos, will actually rotate the turret. On the right-hand side is just kind of a overall wiring diagram of what a proximity sensor would be, like the insides of it. Next slide, please. And so here's a video of my test infrared circuit. And so once I got that all working, next slide, I built a box that will attach to Orion's turret, and the green LED lets you know that there is correct voltage, operating voltage, and the red LED, when it turns on, will detect an incoming, I would say, object. If you want to go ahead and push play. And you are able to adjust the distance on the IR sensor detection.
All right. So for the cost analysis, we have all the prices of the stuff we spent while making this prototype, and our total cost for everything would have been $142.14. Since this is like military grade stuff, the thing that was difficult was trying to find prices for like the materials they would use if they were building this like a full scale. So for our potential full scale materials, we were thinking either like steel or composite material for the armor. We want, or in a real CRAM, they would use a radar system using a Q band instead of what we're using right now, which is an AI camera and an IR sensor. And with a Q band, we would use microwaves or a certain frequency of microwaves to detect where a rocket would be instead of tracking it with a camera. But our prototype is to just show the concept, and this is what we would need. Yeah. So for total hours, we'd need to spend, or our total team hours for this project was 115 team hours, and then here individually is how much we've each worked on this project on our own time. That's about all I got.
All right, so potential contacts. So we were able to talk to Darren Chase, so we can machine our base plate. But fortunately, we're not able to do this for this quarter. Unfortunately, or secondly was Ken Bakerman from the mechatronics department, with David. And potential contacts like outside the school is a Navy cryptologist, Bay System and Raytheon company that probably will be interested in our little prototype.
All right, so just to go over some extra uses as mentioned before, this is just to give you a visual of what that looks like. So at the end of these arms are sensors which can take different actions, whether it be picking up produce or weeding, whatever it may be. The Vision AI allows you to program it so you can say what it is it's looking for and then react based on that. And that is how it can be used for anything other than just military grade weaponry. And next slide. Okay. One of the images, I guess, didn't get saved on the right here, unfortunately. But on the left, you can see Corey's IR sensor that is all assembled. And in the middle, there is a video of what I had got working with a terrible picture of my face for how the sensor works right now. And if you press it, basically the red box will square over my face. And on the right, it'll track my face. And then on the right, there's a readout of what my code is doing. And it's, I'll load up a bigger picture of it, but it's basically saying move right, move up, move left, or move down. And the only reason why it's not connected to the AIY right now is my AIY has a software bug. So I have to get a new one before it can be added. But the code is working. And that wraps up our project so far.
Any questions? I guess we're done.
Any questions or comments for these guys? Before they wrap it up. So are you guys going to finish this one last page to show me the actual part? Is that what we were saying?
No, it was just a bigger picture of the readout of the code on the right, showing that it is tracking my face and sending the signals to the servo to move it.
I'm okay with that. I just want you to add a picture of your actual finished product here. I think your video is fine, to be honest. I kind of think that's pretty cool. You got it to follow your face. So. Okay. No questions or comments from the other team? Do I have them even turned on?
Looks pretty sweet. Did you get the so you got the servos to actually follow the bounding box now?
So I made it so when I try to hook up the servos, I get a permission error that when I followed the GitHub guy who created the AIY, said there's no solution for it. So I have to buy a new AIY, but yeah, the code is tracking my face and is telling the servos which way to go.
Hey, you guys, you didn't turn on the recording?
What?
I thought you were recording this. Did that not get recorded?
It's recorded on ours.
Sweet. Okay.
That's right.
I'm sorry.
That's pretty sweet, though. Getting the bounding box to control servos is a pretty big move.
Yeah, man. It took me forever.
Well done.
Yeah, that's really well done, you guys.
I honestly, like, it sucks, dude. I bought another AIY and I opened it, assembled it last night, and it's a lemon. It doesn't even turn on.
No.
I know, man, because I was like, I really want to get this done. It'll be so cool to show it off.
Yeah.
And I do it last night, finally get it in the mail, and it doesn't even turn on. What a bummer.
That is, man, that's ridiculous.
I know, I got to return it and I'll try again.
So you're taking the AIY and you're getting output off the GPIO pins. Are you using that Arduino Uno to then try and use that as a driver for the servos, or what's driving the servo?
the Arduino is actually the controller, and the Pi is the computer who's sending the code to the controller, because they say use the Arduino for controllers of servos. It's better.
Right. Yeah, it's got a better. It eats up a lot more noise.
Yeah,
It has a better power outage. Okay, cool. So that's your driver board essentially, and your Pi is the actual processor. I dig it.
Yeah,
Cool project, guys.
we had talked about another one that was available, and I shared it with our team, and the one you had showed me as well, Dane. But that one uses a whole different program and different system, so I couldn't follow it. I had to make my own code from scratch.
Nice. Well done. That's not easy to do.
No,
Yeah,
no,
man,
you
thank
did
you.
a lot, man. That's a lot, Orion. All right, guys. Orion, can someone share their screen that can access Canvas on the Auto Shield team? Somebody please pull up Canvas and
Got it.
Yeah.
I can.
share your screen for me. I'll have you go to module.
Yeah, I'm there.
Oh, scroll down to the bottom of the meetings. And we have the group, assess other group. Click on that one. So guys, you're going to grade your own team. Now there is a video, what I'm looking for you to do. If you click on the link there, there's an Excel spreadsheet. And you can go ahead and open it, actually download it.
Oh, I gotta go back here, right?
Yeah. There you go. And then go ahead and make it full screen there for everyone. So team number 1 is going to be you guys. So up on the top where it says team 1, you're going to put Auto Shield. Up on the very top where it says team member 1, you're going to edit that to say Auto Shield.
All right, hold on. This out of the way.
And then the questions are in the Canvas. That's the team learning questions, peer review. And you guys as a team will rate yourselves as a team, how you did as a team, okay? So in case the other two groups bomb you, you guys got to say good things about yourselves. I'm sure they would. I'm kidding.
Hey, David.
Yes.
Yeah, so I think the last TLA that we did, we created each other for that one, the TLA.
You know what? Did I have that open already earlier?
Yeah, see, this one looks just like it.
Yeah, great. So you guys already got it done.
Yeah, so because we already did this on the previous TLA, we
Yeah.
on the discussion
That's
section for our
good. Then
agenda,
everybody should have it done, huh?
then we had like discussion like the grading for each person. Yeah, we saved it on the PDF.
That's for the other one though. This is for the group. You're gonna rate the other group.
Okay.
Oh wait a minute. Did I have you open the wrong one? I'm sorry. Go back to the Word doc. Did I name this wrong? What the hell did I do?
No, that's Corey's.
Yeah, the previous one.
That's
Yeah.
Corey's thing. He
Yeah.
redid it.
That's what I was trying to say. Does that work for
Yeah. Yes.
that one?
That's for the other one, right? Go back
This is for peer. I don't know what you mean by go back to what.
to the Canvas Excel spreadsheet I had up, or to Canvas itself. This one you're gonna grade your presentation. Oh wait a minute. Group assessment of other groups.
Yeah, there's another one.
Yeah, see, this is
here.
I didn't understand.
And there's another one
How
that's
did I
here,
screw that
but it's
up?
pretty much the same thing.
All right, hold on. Son of a.
Yeah, because that's what's open both of those. So technically, we already did this one. which would be peer feedback, correct?
Yeah.
Can I take percent so I can show you?
Sure. Just give me
Right.
Group
close some
assessment.
screens on here. Where do I go? Oh yeah. Okay.
All right, so David, I don't know if you can see it. So last TLA discussion we had was like grading the teams or peer review. So we had the step 4 for the TLA Word document, and at the bottom of it, it has the gradings. The gradings right here, and tells you what to do.
Right.
And
That's
this is
grading.
my version of
That's
it
grading
right
your
here.
own. Grading your own team.
Yeah,
Yeah.
yeah. So is this
But
okay, or we have to redo it
we're
in the
gonna
PowerPoint?
grade. We're gonna grade the other groups. You're grading that grading individual is how you guys work together as a team. We're gonna grade your presentation on the group thing here. Hang on just a sec. I'm trying to figure out how I screwed up my spreadsheet here. Group assessment comments. This is what I should have.
Yeah, but doesn't Martin's Word document work for
No, it's not.
assessment
It's
of peers in
different.
your group?
It's different.
Okay, so it is different. So they have to do that.
I look group comments of other groups. Why is it giving me this? Oh, wait a minute.
Because it
No,
seemed
it's
like
right.
the delay you have for the peers is pretty much the same thing as what I have right now. But it seemed like an older version of it.
Can you go back to your canvas? Why? It looked like it was in a different order.
Peers or group assessment?
Let me see the canvas.
I'm in
Who's-
canvas right now.
Oh,
Hey,
I'm
Dave.
looking at the wrong screen. Sorry.
Dave, will you get this sorted out? Can we start our meeting? We got a lot of
Yeah,
to
go ahead and
go
go
over
to.
today.
Well, I'm gonna just let me sort this out with you real quick. Hit group assessment, other groups, and click on that one. That Excel spreadsheet. That's still not the same one, right? Yeah, you got to download it though. So you're gonna you're gonna grade your own team and the other two teams on that spreadsheet. All right, Dane, you guys got that? You guys can grade them now if you want, and you still got to wait for the other team to grade, and then you got to grade your own team. How you guys did?
So
Okay. No, this is not peer feedback. That's a different thing. That's grading the individuals is the peer feedback.
Mm-hmm. So whatever we have right now, like that we did on TLA discussion, like for example, like
yes,
mine, this one's
that can be for that. Yes.
Okay.
That one can be for the peer feedback. That's 400 points.
Okay.
The one that's 100 points is a different thing.
Right. So
what you want us to do right now is grade the group that just.
Well, you guys got till next Tuesday to get it done. Okay, so war groups, you guys can take off to your own meeting now. Or war, god dang it, what are you guys again? War something.
Water wheel aquatic remediation.
Yes, you guys can go out, get out of here.
I had to think about what war meant.